All right, this is part C of section 11.1. And in this video, we're going to talk about coordinate covalent bonds and resonance structures. So let's first talk about coordinate covalent bonds. And these form when the two shared electrons from a bond come from the same atom. So if one atom donates both electrons to the bond, now it goes around both different atoms, but the two electrons came from one. Once you do that, you couldn't tell the difference between it. It's just like every other ordinary bond. The only difference is that one atom donated two instead of both atoms donating one. And a lot of polyatomic ions are like this, and so we'll show you a couple of these. So let's take a look at NH4 plus. Now understand that the plus means that we are short an electron. So right now I've got three hydrogens. You can see I've got three hydrogens each with one, and a nitrogen with five. And I'm going to add in my last hydrogen, but it's missing an electron. And so if we form bonds here, we'll form bonds between these here, here, here. And this hydrogen here, he's left all alone. He doesn't have any electrons to share. So the nitrogen says, hey, I'll donate both of these. I will give you both of those electrons. Now, when we write this out, and we do it with without the dots, usually the way that they indicate a coordinate covalent bond is that they use an arrow. So we're going to use an arrow to indicate that the nitrogen donated both electrons to that hydrogen. When we're done with this drawing, we should indicate, we usually put like a box or kind of brackets around, I've got not much space here, brackets around this thing, and then put the charge up in the corner. And so we would indicate the charge like that. So let's take a look at another example, and this is SO4 2 minus. 2 minus means we've got two extra electrons. And we're going to distribute those around, and I've kind of set this up already and kind of moved a little bit of electrons around. But you can see that every single one of these, all the oxygens both and the sulfur, have 6 electrons right now. So let's take one of these electrons and give it to this oxygen right here. And then on the bottom, let's give it to this guy right down there. And now if we form bonds here, these guys can share. They can share this one. And the sulfur, he's happy, but these other two oxygens are short 2 electrons. So sulfur says, hey, I'll donate both of these. I'll donate those 2 there, and I'll donate those 2 there. And now we should write this, and the way we should write this is SO. And remember, this one was donated, this one donated both, and then put brackets around it to indicate that we've got this 2 minus charge. So we should indicate that on our diagram here. All right, the last thing we want to talk about is resonance. And sometimes it's possible to draw 2 valid structures for the same molecule. And anytime that happens, that is known as resonance. And let's take a look at this example. We got NO2 minus, and so we've got 2 oxygens, and each oxygen right now has 6, and I've got that 1 extra electron because of the minus, and so I'm going to put it in on this side this time. I'm going to put it on the left, and so we can form a bond there, but on the right we would form a double bond. So you get a structure like this with a single bond, double bond, and of course you would put your minus sign on it. But assuming that this is oxygen number 1 and this is oxygen number 2, there's another valid structure without moving those oxygens around. And I'm not talking about flipping this in space. I'm saying, hey, this is still oxygen 1 here and oxygen 2 over here and the nitrogen in the middle. But I could just as easily have made the double bond on the left side and the single bond on the right side. Anytime that that's possible, that there's 2 ways that you can do that, then you have what we call resonance. And that simply means there's two potential ways that this could be drawn. And actually it could be more than 2. There's sometimes they have 3. for that. So when what they found out though is that all of these are valid things, and the actual thing is kind of a composite of the two different structures that you could possibly have. So it's kind of a mixture between those two in reality. But we can't really draw that. I mean, so originally what they thought was that maybe, hey, this bond, this pair of electrons is just flipping back and forth, just goes back and forth between those, and you get those two structures. But that's not what they figured, later they figured out that that's not really what's happening. What is happening is it's more of a hybrid. You get kind of a 1.5 bond on every side between those. So it's not a single bond, it's not a double bond, it's somewhere in between. And you get that resonance, that possible thing. So that's what really happens, but we draw it usually with those two different structures so that we understand what it is, because we don't really have a way to draw 1.5 bonds. So usually what we do is we draw it with this double arrow kind of thing to say, hey, this is a possibility, or this is a possibility, and therefore we know we have resonance between those two. And that's the end of section 1. So hopefully you've got all of that stuff figured out. Quite a bit of stuff that we did in section 1, so that's why we broke it up into 3 different sections there.